If a function is injective, then that means we can create an inverse, right? Let's see, if a function f sends x to y, but then also sends x1 to y, then I can't create an inverse, because then I would be trying to take this y value and sending it back to x, but then also back to x1, right? And that would not be a function because I can't split up that y value. So I wouldn't be able to go back in that direction. I wouldn't be able to create an inverse. But if it is injective, then every input has a unique output, and I can create an inverse. So let's consider f of x, which is 5x minus 7. And first, let's show that it's going to have an inverse by showing that it is injective. So we let f of x equal to f of, let's say f of x1 is equal to f of x2. And our goal here is to show that x1 has to be equal to x2. So 5 times x1 minus 7 is equal to 5 times x2 minus 7. It seems kind of silly, right? You can probably already tell that x1 has to be equal to x2. Let's add 7 to both sides. Let's divide by 5. Yep, x1 has to be equal to x2. So only one output gets sent to the same, or sorry, no, that would be true. Every input has a unique output. So it is injective. It is going to have an inverse. Let's find it. So if x gets sent to y underneath this function, then we're looking for the map that goes backwards. So we're looking to solve this relationship for x in terms of y. So if y is equal to 5x minus 7, then I want to go from y values and solve for the x value. So let's solve for this x. I add 7 to both sides. I divide by 5. Cool. So that's how I go backwards. So if we name the inverse of f inverse, it will be x over 5 plus 7/5. Right, because that's the function. It doesn't matter if I call it x or if I call it y, but right, it's all about pattern recognition. So our last step is to verify. So by definition, if we did this right, we send f to y underneath f, and then f inverse should send me right backwards to x. So let's see if that's true, because this is really just a composition of functions. Let's take x and map it somewhere underneath f, and then we're going to take that and we're going to map it underneath f inverse. All right, our goal is to get back to x. So I want this to equal x. Okay, let's see if it does. So let's plug in f of x into f inverse. That's f of x over 5 plus 7/5. F of x is 5x minus 7. All right, is this going to work? 5x divided by 5 gives us an x, a minus 7/5, and a plus 7/5. Yeah, so that gave you back x. Let's also show it in the opposite direction. Let's show that f will undo f inverse. Right, I'm hoping to get an x out of this because I want these two functions to undo each other. All right, f is the 5 times something minus 7 function. And what is f inverse? It is x over 5 plus 7/5. All right, when we distribute this 5, we end up with x plus 7 inside that parentheses, and then minus the 7 gives us back x. So this diagram is true. These two functions undo each other.